Last week my terrain looked like this, and now it looks like this. I've managed to reduce the number of top vertices by about half, while also not having taken too much of a performance hit to do so. And I did also manage to get the optimization working for the side faces as well, but I've kind of decided maybe not to use that, and I'll talk about why later. This is a game about exploration and discovery in a high fantasy world. You discover things, collect items, kill monsters, and gradually explore the world. And what would happen if you zoomed out far enough in the world that the game frame rate dropped to 2 frames a second because it's trying to draw too many faces? Well, we're going to fix that today. The face merging algorithm itself is actually pretty straightforward. You take a single face on the terrain and check to see if its neighbours in one direction can be merged into it. You check to see if things like the voxel colour and also the ambient value are compatible, because if they're not the same for the merged faces, then it would just end up looking wrong. Once you've then expanded as far as you can on one axis, you expand all the faces on the next axis until one of the faces can no longer be merged. When you reach that point, the face gets committed and you repeat the process until every face has been checked. For things like terrain especially, where you have lots of flat bits, even a simple algorithm like this can do quite well. I implemented a similar algorithm in a separate video, so actually I've pretty much got all of this code already written. The problem I had was that this was not being done offline. It was all going to happen on the user's device as part of the map gen procedure, so I had to make sure it was as fast and efficient as possible. And this led me to one of the most interesting and also slightly paradoxical realizations of this whole thing, which was that it might actually be more efficient not to merge some of the faces like the faces on the side of the terrain. Merging the side faces is a much more complex job due to the nature of how the terrain works. This is a height map terrain, meaning it fits perfectly onto a 2D grid. All of the faces can actually just be merged like this, meaning they're all projected onto a 2D coordinate system and you're guaranteed to never get a crash. I can't actually do that for the side faces because, say I had 2 hills in the scene, they would conflict with each other in my would-be coordinate system. My only choice then was to go through the data structure in slices in order to get hold of the data that actually needed merging. This is way more intensive on memory and CPU though, because I have to set up a 3D data structure here. For the average world in the game right now at 600 width and height and a depth of 25, that would be 72 megabytes for memory for the CPU to allocate and have to jump around. And not to mention that would be awful for cache efficiency. All in all, we're probably only talking about a few seconds to actually merge the faces, but I do need to think about those users with less powerful setups, because bear in mind I am thinking of targeting this for mobile. So paradoxically it might actually be faster just not to merge the faces, and to be honest modern day GPUs are quite good at pounding out triangles anyway. But having said that, I think once I can imagine up a more efficient algorithm to actually merge the faces, then I'll probably just have a go at it anyway. I mean, it can't hurt, right? The thing is, I wouldn't really know because I haven't really got around to properly profiling it yet. This week was Easter and I spent most of it just back at my parents' house doing other stuff. I helped build this pond in my parents' garden, which turned out to be beautiful, as I'm sure you can see. So less dev work was done this week. Next week though, next week. One of the things I did do this week though was start re-architecting the world gen system. Basically, I wanted to make it more flexible because right now it's all implemented in C++. My closed source part of the code, which is the bit that contains the thing that I'm actually going to sell, is essentially just sat on top of the open source base as if it was a mod. Now the problem with that is that it can only really interact with the scripted content. It can't change the C++ stuff in any way. So if I want to change the map gen, I'm kind of stuck. And to make matters worse, the map gen all runs on a worker thread at the moment, whereas scripts can only run on the main thread. So map gen is getting much more flexible. You can now define your own steps, and also I've re-architected the engine in a way that scripts can now run on the worker thread, which was kind of a big job. So that's all going to take a while, and to be honest there's a lot of work that has to go into it, so I think I'm just going to come back to it some other point. So that's it for this week. See you in the next one.